Okay, this is the paper 2, and October, November 2019, and the variant is 2. Question number 1 is distinguish between the vector and the scalar quantity. So scalar has a magnitude only, and the vector has magnitude and direction. So we have to write magnitude and direction for the vector and only magnitude for the scalar. And the next question is E is equal to Q over x square B. So by the definition of the electric field, we have to show this unit. So E is equal to F divided by Q. F is kilogram meter second power minus 2 divided by charge IT ampere second. So it's kilogram meter second power minus 2 minus 1 and ampere power minus 1. So finally it becomes kilogram meter ampere power minus 1 second power minus 3. The next question is we have to show the unit of the B. So B can be written as Q divided by EX square. Q charge ampere second, E units kilogram meter ampere power minus 1 second power minus 3 and X distance so meter square. And finally after calculating this it becomes kilogram power minus 1 ampere power 2 second power 4 and meter power minus 3. And the next question is question number 2. Define the acceleration. Rate of change of velocity is called acceleration. Now this is a question. Ball is dropped from this with initial speed 0. It reaches to this point P, and before reaching this P, it covers 0.28 meter distance. Now the question is, explain why the force due to the air resistance may be neglected. So the answer is, magnitude of the air resistance is smaller than the weight, so we can ignore it. The next question is, calculate the time taken for the ball to fall from rest to the point P. So distance ut plus half at square, distance 0.280. Initial speed here 0, 1 by 2, 9.81 t square. So t square this, and then finally we can calculate t is equal to 0.24 second. So this is the time. Next part is determine the time interval during which the beam of the light is broken by the light. So we have to calculate 2 times. First, when it reaches at the surface of the ball, and then at the bottom of the ball. So first when it's touching the beam, and second when it's leaving the beam. So when ball crosses the light beam, so D becomes 0.28 distance covered plus size of the ball, so it becomes 0.36. So distance for this 0.36, S is equal to ut plus half at square, 0.36, 0 initial speed, 1 by 2, 9.81 t, t is 2.7, and the difference of these 2 times is equal to 0.03. The next question is, the ball is different, its density is low, and air resistance cannot be ignored. State and explain the change. Due to air resistance, resultant force or acceleration, it decreases. Ball crosses the beam with a small speed, slow speed. Thus, time taken by the ball to cross the beam will be longer than 0.3 seconds. And the next question is, state Newton's third law of motion. Simple, every action has reaction, equal in magnitude, opposite in direction, and the kind of the forces is same. And the next question is, this is moving with 5v, this is at rest, both move with the same velocity. So MA, UA, MB, UB, MA, VA, MB this. So MA, first velocity 5v, this is at rest 0, MAV, MBV, because after collision, after interaction, both are moving with the same velocity. So it becomes 5 MAV, and this minus 5 MA, 4 MAV, we cancel. So MB over MA ratio is 4. Now we have to calculate the kinetic energy after collision and kinetic energy before collision. Look, this half MVA square plus half MBVB square or V square and divided by total kinetic energy before. So 1 by 2 MA 5V square plus 0. So M2 cancel, MAV square, 4 MAV square over 25. So MA cancelled, so it becomes 5 divided by 25, so which is 0.2. So the answer is 0.2. And the next is state the value of the ratio for the perfect elastic collision. Look, kinetic energy is conserved in the perfect elastic, but we can't write it here because it's state. We just have to write the answer, so our ratio is same, 1, because both are equal, conserved, so the ratio will be same. And next is According to Newton's third law, change of momentum of A is equal to change of momentum B. Initially, B is at rest, so no momentum. And what is the change of momentum of A? How many boxes? 1, 2, 3, 4 down. So it must be 4 up. 1, 2, 3, 4, and then becomes constant. So this is the graph. Next question is, describe quality the magnitude and direction of the resultant force, if any, acting on the block X in the time interval 0 to 20. Look, 0 to 20. Gradient is 0, so force is 0, because momentum time graph, gradient is 4, so force 0. And from 20 to 40, this is the line with negative gradient. It's constant, force is constant, but opposite to the direction of motion of the momentum. And this, sketch the graph. So this is the graph. Next question is question number 4. A sphere in the liquid accelerate vertically downward. So the resistive force, viscous force will be upward. It opposes the motion. In the variation, if any, in the magnitude, it increases because the resistive force increases with speed. When speed increases, it also increases. And the next, state the principle of the moment. In the state of the equilibrium, sum of clockwise moments is equal to sum of anti-clockwise moment. And next, the question is by using the pivot C. This is the C pivot. We have to calculate FB. Look, these two forces are acting in this direction and this force in this direction. So clockwise 1, anti-clockwise 2. So we can write F1 D1 is equal to F2 D2 plus F3 D3. So F1 is FB. Its distance from the pivot is 5. Then F2 is 380. Its distance from the pivot 2.5 and 750, 1.6 distance. So the final answer 430. Then the man walks towards the ND. The beam is about to tip when FB becomes 0. Definitely when this person will move to this point, this force becomes 0. So this force is acting in this direction and single force this acting. So two forces only. So F1 D1, F2 D2. F1 is 380. Multiply its distance from the C is 2.5 and this man weight 750 and its distance 2 minus X. So it becomes 950 or 750, 2 minus X. So X becomes 0.7 meter. Next question is, state what is meant by the wavelength of the progressive wave. Distance between the two consecutive wave fronts, two consecutive crests, are two in-phase points is called wavelength. Next question is, we have to calculate the frequency. Look, frequency is 1 over time period, but time period is the product of time-based setting multiplied by number of the divisions for one wave. So the number of divisions for one wave is 2 centimeter. So time-based setting given here, 2.5 millisecond into 2, it is 5. So 1 divided by 5 millisecond, it becomes 200. And the next is, this is the source of the wave. One path is this, other path is this. So one path longer than other. So show that the difference is, path difference is 6.4. Look, this can be calculated, BC, hypotenuse square minus perpendicular square. This is 19.2. Now this way distance covered is 8 plus 19.2 minus this 20.8. So this is 6.4. So it's proved. Explain why the intensity, why an intensity maxima is detected at point C. Look, for the maxima, for the constructive interference, path difference must be n lambda. And n is the whole number, not decimal. So path difference 6.4, n required, wavelength is given 1.6. So n is 4. So definitely it's a whole number. So maxima is formed. Determine the difference between the time taken. So what is the difference of the distance? That's a path difference. So distance, speed into time, path difference divided by speed, 6.4 divided by 320. This is the time taken by the two waves, right? This is the time difference. Next, the wavelength of sound increases. Calculate the wavelength of the sound when the intensity maxima is next detected. Look, path difference and lambda. Path difference will remain same because the position same. So path difference and lambda. So n and lambda both are inversely. When lambda increases, n decreases. So the next smaller number, whole number, is 3. So 6.4, 3 lambda. So lambda is 2.1. Okay. This question number 6 is Kirchhoff first law. Simple. At junction, sum of the current entering the junction is equal to sum of the current leaving the junction. And the graph is given, current at the y-axis and the voltage at the x-axis. So the gradient is resistance. So V is equal to IR for this voltage, diode resistance required. So V over I, voltage this, look at this, current is 7.5 milli, so it becomes 80. Describe qualitatively the variation in the resistance of the diode as V increases from 0.6 to 0.7. So look, the gradient is increasing, so the resistance will decrease. And the next is, in this diagram, diode and X are series, Y in parallel. So question is determine E. Look, for the diode, 7.5. So it means from the graph, for the 7.5, this is 0.6 volt. And for the resistor X, 7.5, this is 0.3 volt. So both are in series. So both voltages are added, 0.6, 0.3. So total EMF becomes 0.9. And next we have to calculate the resistance of I. So first calculate the current, this minus this, 9.3 minus 7.5, 1.8 milli. So R is equal to V over I, 0.9 divided by 1.8 milli, so it becomes 500. And then power of the diode, this is the current, it's square, resistance 80, so 4.5 10 power minus 3. Now, the next question, the cell is replaced with 0.5 and negligible. Determine the new current in the diode. Look, both are connected in series, so we have to add the voltage, okay? Which current, suppose this one, is giving the total 0.5. Look, 2.5, here voltage 0.1, and for this diode it's 0.4. So look, 0.1 and 0.4, it becomes 0.5. So this is the current passing through the diode, so 2.5 milliampere. And the last question is, nucleus of plutonium, this emits alpha particle. When alpha particle emitted, proton number decreases by 2, mass number by 4. So 94 minus 2, 92 is the proton number. And mass number minus proton number, this is the neutron number, so 142. Next question is calculate the number of the plutonium nuclei must decay in time of 1 second to produce this power. Look, power energy divided by time. Already energy given from one nucleus is this. We have to convert this in joule. So 1.6 in 10 power minus 3 is multiplied for this mega electron volt divided by time 1. So this is the energy available from one nucleus decay, and the total energy required is 0.15. So 0.15 divided by required this power divided by available power. So this is the number. So number is equal to required divided